Hello friends, so this is the third question that we are going to discuss on the application of Thevenin's theorem. So here we have this circuit which is drawn before you, and we have to find the current flowing through this 15 ohm resistor using Thevenin's theorem. Okay, so in order to do that, first what we have to do is we have to find the Thevenin equivalent circuit across these two terminals. Okay, we have to open circuit this 15 ohm resistor, remove it, and find the Thevenin equivalent of this network, excluding the 15 ohm resistor. So first we have to find VTH, Thevenin voltage, then RTH, Thevenin resistance. Okay, so let us redraw the circuit. (180 volt), 90 ohm, 2 ampere, then 90 ohm and 60 ohm. This is open circuited. 15 ohm is removed. The voltage across it is VTH. Okay. Now we can apply mesh analysis here. So let us consider two currents, I1 and I2, flowing in this direction. We have assigned the directions of the mesh currents. So here the VTH is the current I2 flowing through 60 ohm resistor. So VTH is 60 I2. This is a very important equation. The voltage drop across the 60 ohm resistor. So in order to determine VTH, we have to determine I2 first. Okay. Another important thing to notice here is these two meshes have a independent current source in between. So it is a super mesh. This whole two meshes combined together, it is a super mesh. So we will apply directly the KVL here. And an important auxiliary equation here is that I2 minus I1. Here I2 is going upwards, I1 is going downwards in this through this current source. So I2 minus I1 is equal to 2 ampere. This is another important equation that will come into play. Okay, because 2 ampere is upwards, so we have to take I2 as the reference. I2 minus I1 is equal to 2 ampere. So now let us apply KVL in this super mesh. Let us assign the voltage polarities. Okay, so starting from here, 180 minus 90 I1, I am using the second sign dominating KVL method. I have posted a video related to application of KVL. You can check that out. Minus 90 I2 minus 60 I2 is equal to 0. So we have to determine I2. So let us convert all the I1s in terms of I2. So I1 here is equal to I2 minus 2. Okay, so in place of I1 we will replace I2 minus 2. That implies 180 minus 90 into I2 minus 2 minus, this is 150 I2 is equal to 0. That implies 180 minus 90 I2 plus 180 minus 150 I2 is equal to 0. That implies 360, 180 plus 180 is 360 minus 90 and 150, it is 240 minus 240 I2 is equal to 0. That implies I2 is equal to 360 by 240 ampere. Okay, 360 by 240 ampere, which is basically, if we cancel it by 12, that is 3 by 2 ampere. 3 by 2 ampere. I2 is 3 by 2 ampere. VTH is 60 I2. VTH is 60 I2. So VTH will be 60 into 3 by 2, which is equal to 90 volts. VTH is 90 volts. So we have calculated VTH is equal to 90 volts. Let us keep it. So we have determined the Thevenin voltage across the 2 points which we got by open circuiting the 15 ohm resistor. By removing the 15 ohm resistor and open circuiting, we have calculated the Thevenin equivalent voltage. Now we have to determine the RTH. Okay, the Thevenin resistance across the same 2 points. Okay, so let us do that. Okay, so we have already calculated the Thevenin voltage. Now we'll determine the Thevenin resistance across these 2 points. So in order to determine the Thevenin resistance, we have to fulfill one condition, is to deactivate the independent sources. Okay, independent sources only we have to deactivate. So how to deactivate? The voltage sources are replaced by short circuits, current sources are replaced by open circuit. So now we have to find out the equivalent resistance between these 2 points. So here we can see 90 ohm and 90 ohm are in series connection. The equivalent resistance is in parallel with 60 ohm. So RTH is simply 90 plus 90 parallel with 60. So it is 180 parallel 60, which is 180 into 60 by 180 plus 60, which is 180 into 60 by 240. So 60 to 40, it is 4, and 180 by 4 is 45, 20, 45, yes, 45. 4 into 520, yes, 180, yes, 45. So RTH is 45 ohms. Okay, so we have determined both VTH and RTH across the 2 points of 15 ohm resistor. We removed that. So now we can draw the equivalent Thevenin circuit. Okay, so the equivalent Thevenin circuit will be VTH 90 volt, RTH 45 ohms. Okay, these 2 points. Now our objective is to find the current flowing through 15 ohm. So let us reconnect the 15 ohm resistor back. So this current I flowing through it is total voltage by total resistance, which is 45 plus 15 ohm, which is 90 volt by 60 ohm. So it is 2 dividing by 30. So it is 3 by 2 ampere, which is 1.5 ampere. Okay, so you saw how we did that. Our first objective using any theorem, in this case the Thevenin theorem, is to simplify the circuit. Okay, that is the first objective of any network theorem, simplification of the circuit. Here in the question it was asked to find the current flowing through the 15 ohm resistor. If we would have gone by normal procedure without using network theorem, we could have used nodal analysis, mesh analysis, but it would have been a little bit time taking. So it depends on in which method we feel comfortable. Some students like the network theorem approach, some students like the normal, mesh nodal source transformation. Yeah. And in some cases you would have to combine all of them. All the theorems concepts will be required. So here we had many ways to solve it. We could have used superposition theorem, we could have used network theorem, we can also use Norton's theorem. Norton's theorem we have not discussed, but we can also use that. So what we did is first we removed the 15 ohm resistor. Okay, then our objective was to find the equivalent representation of this portion of the circuit across the 15 ohm resistor. This, to simplify it, 180 volt, 90 ohm, 2 ampere, 90 ohm, 60 ohm, how to represent it in a simple way. That is the objective of Thevenin theorem, to represent this portion of the network across the 15 ohm resistor in a simple way. All of this within the blue dotted region is same as 90 volt being connected in series with 45 ohm. See, all of this is reduced to one voltage source in series with a resistance. Then it is simple to determine the current I. Just reconnect the 15 ohm resistor back, find out the current. Or if it is asked to find the voltage drop or the power absorbed by the resistor, you can do that. Okay, so this is the whole point of using the Thevenin theorem, simplification of the circuit for analysis or solving purposes. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to electrical, electronics, instrumentation and communication engineering. Have a great day. Thank you very much.